So Newton's laws of motion. So this is the particular branch evolved due to Newton. So Newton is the one who gave a strong foundation to mechanics. So we can say this has evolved in the year 1647 to 1720. It's not like that. Much before that, Kepler, Galileo, everyone had given their ideas, but strongly in terms of concrete evidences and theories, Newton put forth these ideas. So that's why basically we say that it has evolved in the year 1647 to 1727. What we are going to study in this particular chapter is, see, here in kinematics, in chapters earlier we have studied kinematics. There we have studied only the effect, means why the body is at rest, why it is motion. That reason we are not found, means who is the cause for the motion, that we are not studied. But here in dynamics what we are going to study is the cause for that particular motion, why that particular motion has happened, that we are going to study it here. Okay, let's for an instance understand it is an object, it's a body. Okay, this body was moving with the initially velocity with u, later with some time t its velocity got changed by v. Okay, that means the state of the motion got changed. Earlier with velocity u, now the velocity will become v. So what is the reason for this, what is the cause for this, is why this particular motion has occurred, why this change has occurred from u to v. That why is explained in this, that is the reason for this is nothing but the force. That force we are going to study it in this particular chapter. Now the thing comes, what do you mean by force? Force means what? Force is a cause that changes the state of motion. So what is that? Force is a cause that changes the state of motion. So force is a vector quantity. Okay, so its SI unit is Newton, and in CGS we express it in terms of dyne. Okay, so vector quantity means, what is the vector quantity? It has both direction as well as magnitude. Now when it comes to force, it is different types of forces. One type of force is contact force and other one is non-contact forces. Okay, in contact force what we are going to study is, by virtue of the physical contact this force comes into picture. So different types of contact forces we have, that is tension force, normal reaction, frictional force. In non-contact force we have gravitational force, electrostatic force, magnetic force, nuclear force and weak nuclear forces. Okay, or weak forces also we simply call. So but as far this Newton's laws of motion chapter 11 is concerned, we are going to study a few types of forces. They are these forces, and that is all these three contact forces and gravitational forces. It's not like that even we'll be going to study this, some numericals will be coming to picture, but when we study all these things, these forces we are going to study in detail in the class 12th. So there in miscellaneous questions we will be interacting with all the kinds of forces only, but as far as the syllabus is concerned, we are going to study these contact forces and gravitational force in particular. Okay, now coming to, first we will discuss with gravitational force. Gravitational force means, this is the gravitational force. Let's assume, by virtue of in physical world we have learnt, by virtue of body's mass, force comes into picture. Among them, that force we call it as gravitational force. Okay, and this force also simply call it as weight of an object and all. Let's consider this is an earth. Okay, let's say a body is thrown up. Okay, this body is thrown up. Obviously we know, by our common sense we say, we know it very well, that any body thrown up comes down. Or if you consider this body is thrown here, it comes down. Okay, that means why it is coming so? It is coming so because of a force. What is that force? That force is nothing but a gravitational force is responsible for this body to come down back towards the earth. So here this gravitational force acts or comes into picture by the virtue of its mass. Earth is a massive object and this body is also has mass. So among this massive object, this force exists. So this body comes here. So always the direction of force, that is gravitational force, acts toward the center of the earth. So let's suppose if you consider this in a spherical surface, somewhere here if you have a center, any body thrown up comes back to the earth. So the direction of force, that gravitational force, always act toward the center. Okay, so we should not say normal, always act toward the center of the earth. Okay, so in detail we are going to study about gravitational forces and all these things in a particular chapter named gravitation, chapter 8. There we will be studying in detail. So the force that exists between the quantitatively, if we have to express it, F gives given by F is equal to G m1 m2 by r square, where G is called as universal gravitational constant. Okay, now so this is the gravitational force. If we have to take, for example, this is an inclined plane. In inclined plane, I kept an object here. Okay, now where is the force acting? My question, is it normal or is it toward the center? If it is normal, means it is like this. It should go like this. Is it happening like this? No. Always it should act toward the center of the earth. Say, so we have kept an object here. It should come down always. So the force act should act where? It should act toward the center of the earth. Okay, right. So what you understood here? Gravitational force is always act towards the center of the earth. So that is the key point in this heading. Okay, now coming to what is normal reaction. Say for example, we have kept an object body of mass m on a surface. So there is a downward force. As I said, in the gravitational force, always a force act downwards, that is by virtue of mass. Earth exert a force downward, that is mg is acting downwards, and this surface in return, this surface when it is kept on this body, when kept on surface, it also exert a force that is called as normal reaction. So this normal reaction is exerted by whom? By surface. In turn, this body also exert a force equal in magnitude, opposite in direction to the normal reaction downwards here, that is n. This n is for what? This n is due to the surface exerted on the body. This n is what? This n is the force exerted by this body opposite to this force downwards here. Okay, so normal reaction always exists or comes into picture in perpendicular to the surface. So always normal reaction acts where? It acts perpendicular to the surface. Okay, now here normal reaction is perpendicular to surface, or normal reaction is perpendicular to the point of contact, we say it. Okay, let's take into picture one more example of this. Okay, let's consider here an inclined plane. Okay, an inclined plane is there. You can notice here on this inclined plane we have kept a body of mass m. Okay, we know here already we have discussed here, maybe you know, in gravitational force, just I quoted this example. You can notice here the same inclined plane. So where the gravitational force acts toward the center. Here it will act gravitational force. Okay, that is mg. Now when you come here, the same diagram I have taken. Okay, so where is the normal reaction? This is the body. This exerts normal, the inclined plane exerts normal reaction perpendicular to it, and downward there is one more force, that is mg, which is acting toward the center, and in turn this body is also exerting a force perpendicular to it opposite in direction, that is n. So if you have to picturize it like this, so let me put it here. This is a body, here normal reaction by the surface downwards mg gravitational force, and here which is perpendicular to it, that is n, that is exerted by the body on the surface. Okay, this is called as normal reaction. This is what? Gravitational force. Understood? So the key point in this normal reaction is what? Normal reaction always exist perpendicular, is always normal reaction is perpendicular to the surface or point of contact between the two objects. Okay, so this is normal reaction.